Today our topic is linked list. Before learning this video, please consult our previous videos on linked list. So we already learned linked list can be defined as collection of objects called nodes that are randomly stored in the memory. A node contains two fields, that is data stored at that particular address and the pointer which contains the address of the next node in memory. The last node of the list contains pointer to null and the first node address is stored to external pointer or header. So there are mainly three types of linked list: singly linked list, circular linked list and doubly linked list. So what is singly linked list? Singly linked list can be defined as the collection of ordered set of elements. The number of elements may vary according to the need of the programmer. A node in the singly linked list consists of two parts, data part and link part. Data part of the node stores the actual information that is to be represented by the node, while the link part of the node stores the address of its immediate successor. So, we already learned many operations on singly linked list. Today we will learn more operations on singly linked list. So, our first operation is insert a new node after a particular node. Means a particular node info is given, I have to insert a new node after that node. So, what should be the discussion? See the discussion. Insert a new node after a particular node. So, this is our linked list. This is our first node. First node address is stored in external pointer, that is header, and last node next is null. And I want to insert a new node. New node info is, say, this node info is 44. And I want to insert this node after 33. Means after 33 I want to insert, and this node after this node, and this node info is 33. So what should be the function? Here function name is insert after. I am passing the address of external pointer or header, that is this 600. So struct node double star ext means ext is an address. That address also hold an address, and that is the address of the node. So ext is an address, that is 600. 600 or another address, that is 1000, and 1000 is the address of this node. So I am passing the address of external pointer, and int x, x is that node info after which I want to insert, and int y means our newly created nodes info. So x is 33 and y is 44. Now I declare two variables, struct node star p and star q. P can hold address of any node, q also can hold address of any node. So p can hold 1000, 2000 in this way, q also can hold 1000, 2000 in this way. I write p equal to star ext, means p holds the value at external pointer. Value at ext means ext is 600, star ext means value at 600, it is 1000. So this is our p. Actually p holds address of the first node. So p is 1000. First I have to create this node using malloc. So malloc allocate at the time of run struct node size memory chunk, and it returns starting address of this memory chunk, that is q. I have to typecast this struct node star because q is the address of this node. So I have to typecast it. So malloc allocate at the time of run struct node size memory chunk, and it returns the starting address of this memory chunk, that is q. And what is q arrow info? It is this y. So q arrow info is y. Now in this way I just create this node. Now some cases. First case is if p is null. P is null means if star ext, p means star ext value at ext. See in this position. Here if this one is null, then no linked list is there. So if p is null, that is if external pointer is null, then it is impossible to insert because no linked list is there. So how you can insert a new node after a particular node? So write one printf statement, impossible. Otherwise normal case means I have to traverse the whole linked list. till we get that particular node whose info is 33, and I want to insert our newly created node after 33. So first I have to traverse the whole linked list. So I start one while loop. While p not equals to null. Is p is null? No, p is 1000. Is p arrow info is x? No, it is 11, not 33. Then what you have to do? You have to increase p. So p equals to p arrow next. Now our new p is this node. This node will be our new p now. Again you have to check. While p not equals to null. Is p is null? No, it is 2000. Is p arrow info is x? P arrow info is 22, not 33. Then what you have to do? P equals to p arrow next. So p is now this node. Now check. Is p is null? No, it is 3000. Is p arrow info is x? Yes, it is 33. So I get our required node. Now I have to insert our new node because both conditions are true. So I get our required node, this node. After this node, I have to insert our newly created node, that is this Q node. So what should be the coding? See, I want to insert Q here. Okay. So if I want to insert Q here, Q arrow next should be 4000. From where I can get this 4000? It is now in P arrow next. So first you have to write Q arrow next equals to P arrow next. That is P arrow next is 4000. I get 4000 from P arrow next and I insert it to Q arrow next. So this is 4000. And P arrow next is Q. Means here I have to give Q. Why so? Because I want to insert this node here. Say here. I want to insert this node here. So after P, I want to insert our newly created node, this Q. So P arrow next should be Q. But remember one thing. If I write this line first, P arrow next equals to Q. If I write this line first, then I can't get this 4000. Because if I insert Q here, I erase 4000. So first you have to write this line Q arrow next equals to P arrow next. First give 4000 here. Then you have to write this line P arrow next equals to Q. Remember this sequence. This sequence is very important. Now I am showing the total function. So in this way, you can insert after a particular node whose info is given. Our next function is delete a node after a specified node. Means a particular node info is given. I have to delete the node after that node. So see the discussion. Delete a node after a particular node. Okay. So I want to delete, say after 22, I want to delete. So I want to delete this node 33, whose info is 33. I want to delete this node. So the info is given, info is 22. After 22, I want to delete the node. So function name is tail after, and here I am passing the address of external pointer, that is this 600, and x. X is that particular node info after which I want to delete. And return type is integer because I want to return the deleted node info. That is, if I delete 33, then I return 33. Now see, I declare two variables p and q. P can hold address of any node. Q also can hold address of any node. P equal to star xt means value at ext. Ext is 600. Value at ext means 1000. This is P. So P holds address of the first node. Now if empty linked list means if external pointer contains null, means here in place of 1000, if it is null, means no linked list is there. If no linked list is there, I can't delete a node after a particular node because no nodes are there. So just give one printf statement, impossible. Otherwise, normal case. I start one while loop and I have to search whose info is 22, that particular node, and I have to delete after that node. So I start one while loop. While p not equals to null. Is p is null? No, it is 1000. Is p arrow info is x? It is 11, not 22. So what you have to do? P equals to p arrow next. So our new p is this node. Again check. While P not equals to null. Is P is null? No, it is 2000. Is P arrow info is X? Yes, P arrow info is 22. So I get that node. After this node, I have to delete. But if after this node, there is no node. Say if P arrow next is null, means here if in place of 3000, if it is null, means this is our last node in our linked list, and after this node there is null, means there is no node. So if P arrow next is null, then no node is there. So deletion is impossible because no node is there after this node. So I have to check whether P arrow next is null or not. If P arrow next is null, means after this node there is no node. So I just write one printf statement, impossible. So I have to delete the node after 22. So I have to delete this node. So what should be the coding? Q equals to P arrow next. So this node is Q. Means after P, P arrow next is 3000, it is Q. K equals to P arrow next arrow info. So K means what? K means this 33. P arrow next means 3000. Arrow info means 33. K. K is 33. Actually, I want to return this deleted node info. That is, I have to return 33. So return K. Free Q. So deallocate this space. And P arrow next should be what? This 4000 because I delete this node. So P arrow next should be 4000. From where I can get this 4000? It is P arrow next. P arrow next means 3000, arrow next means 4000. So P arrow next here I have to give P arrow next arrow next. You can also write in this way. P arrow next equals to Q arrow next. This coding is also true. So in this way, you can delete a node after a particular node whose info is given. Our next function is erase all nodes from the linked list. So there is one linked list. I have to erase all the nodes from the linked list. Now, after deletion of all the nodes from the linked list, external pointer contains null. Now, see the discussion. Erase all nodes from the linked list. So, this is our linked list and external pointer contains the address of the first node. Now, I have to delete all this node, that is erase all this node, and after deletion of all these nodes, external pointer contains null. So function name is erase. I am passing the address of external pointer, that is this 600. Now I declare two pointer variable of struct node start type. P can hold address of any node. Q also can hold address of any node. P equal to star ext. So our starting node is P. So P holds the address of the first node. Now I start one while loop. While P not equals to null, Q equals to P, P equals to P arrow next. So first time is P is null, no it is 1000. So P equals to P arrow next. So P equals to this node and Q equals to this node. Q equals to P. So this is Q. Q equals to P, P equals to P arrow next. Then free Q. Free Q means you have to delete this node. Again, while P not equals to null, is P is null? No, P is not null. Then P equals to P arrow next, free Q. So now our new P is this node. Q equals to P. So this is our new Q and free Q. So now I have to delete this node. Again, is P is null? No. Q equals to P, P equals to P arrow next. So this is our Q and this is our P and I have to delete this node. Free Q. Again, is P is null? While P not equals to null, is P is null? No. Q equals to P, P equals to P arrow next. So this is Q now, Q equals to P and P equals to P arrow next. So P is now null. So P is null now. Q equals to P, P equals to P arrow next, P is null now, free Q. So again you have to delete this node, free Q. Again, while P not equals to null, but P is null now. So deletion completed. Now what you have to do? You have to give in external pointer null. So star ext equals to null. Value at external pointer, it should be null. In this way, you can erase all nodes from the linked list. So now we will see how to write a C program to implement following operations of linked list. Insert a new node after a particular node. If the info of that particular node is given, delete a node after a specified node if the info of that specified node is given, and erase all nodes from the linked list and give external pointer null. So see the coding. So this is node structure. These are required prototypes. End insert function is used for creation of a linked list. Display function is used for showing the total linked list. Insert after function is used for insert a node after a particular node whose info is given. Del after function is used for deletion of node after a particular node whose info is given. Erase function is used for deletion of whole linked list, and count function is used for counting how many number of nodes are there in the linked list. In main, I initialize xtptr as null because when I start our program, there is no node in the linked list, so xtptr is null. I declare xtptr in this way: struct node star xtptr. xtptr can hold address of node. Now this is the index. Take the choice from the user. I use here switch case control statement. Switch choice. First case is end insert. How to call end insert function we already discussed in our previous video. Second case is insert after. First, take the node after which you want to insert, take that node info. Then supply the number, means supply our new node info, means supply the number which you want to insert after that particular node. Okay, so that is why. Then call the function insert after by passing the address of xtptr x and y. Case 3 is display function. Call display function by passing the address of xtptr. Case 4 is del after function. First, take that node info after which you want to delete, that is x, then call the function del after by passing the address of xtptr and x. This function returns the deleted node info, and that is stored in the variable y, and I print y. Now erase function. Before calling erase function, first I call count function. Count by passing the address of xtptr. Count function returns how many number of nodes are there in the linked list. Say it is y, I print y. Then call erase function by passing the address of xtptr. And after deletion of all nodes, after calling erase function, again I called count function by passing the address of xtptr. And this function returns total number of nodes in the linked list. Because after deletion of all nodes, no nodes are there, so count returns 0. So I have to check whether count returns 0 or not. If count returns 0, then I can say that all nodes are erased. And case 6 is count. So count, it returns total number of nodes in the linked list. Now case 7 is exit. Now this is our display function. We already discussed display function in our previous video. This is end insert function. We already discussed end insert function in our previous video. This is insert after function. This is del after function, and this is erase function, and this is count function. We already discussed in our previous video. So when I run the program, see, supply your choice. First I create the linked list by calling an insert function. So 1, supply the number of node you want to insert, say it is 5. So 11, then 22, then 33, info of third node, info of fourth node, info of fifth node. And after that I want to see. So this is our linked list now. Now insert after function, call insert after function. Say I want to insert after 44, 45. So call insert after function, it is choice number 2. Supply the node after which you want to insert, it is 44, and the number which I want to add, it is 45. So again I want to see our linked list, so it is 3. So now the linked list is like this. After 44 there is 45. Now del after function, I want to delete after 44, 45. So I want to delete 45 again. Okay, I insert 45, now I want to delete 45. Okay, so delete del after. So it is choice number 4. I want to delete 45. So supply the node after which you want to delete. I want to delete after 44. So the deleted node is 45. Now want to see the whole linked list. It is 3. Case number 3. This is our linked list. See, there is no 45. Now I want to count the total number of nodes. 6. Total number of nodes are 5. Now call the function erase. I want to delete the whole linked list. Okay, so 5. So total number of nodes are 5. After erasing, total number nodes are 0. So deletion is successful. Now case number 7, exit. So this is your programming assignment. Write a C program to implement following operation of linked list. Insert a node after a particular node whose info is given. Delete a node after a particular node whose info is given. Erase all nodes from the linked list. For getting more and more updates, please like, share and subscribe my channel. That's all for today. Thank you.